I'm Praveen, and I work as a data scientist here at OCTAVE. I'll get started with the masterclass. So this is our agenda today. So first, we will look at what machine learning is and what are some of the interesting applications there are in machine learning. And we will look at model selection and metrics. And then we will look at translating insights into action. So that's the agenda for today. So we will look at what sort of analytics that we use in our day-to-day lives. So we use GPS in our day-to-day lives, and GPS has advanced analytics and machine learning algorithms embedded to it. So it uses different algorithms to identify where you are, whether you are inside a building or on the road, so things like that. So also it uses, we also use autocomplete on our phones. So still it uses different algorithms, things like LSTM algorithms to identify the autocomplete suggestions. And then when it comes to instant ride booking, there are also, it uses a number of different machine learning algorithms. So restaurant recommendations use recommendation engines. So these are some of the applications that we actually use. So there could be times that we are using machine learning algorithms that are not very apparent to us also. So can someone say some of the applications that are not very obvious to us, but we are still being used, but like things like we are still being surrounded by it, but we are not really aware of it? Can someone say an example or two? So say for example, things like, so when we go to an internet website and we watch a video of a certain product, you sometimes get to see an advertisement of that product too. So that's another example of use of machine learning. So why did I as the first slide? It's because we are surrounded by machine learning all the time, and it has been a explosion of data science recently. And some of these technologies haven't existed for existed 10 years back, but it has become so much more apparent right now around us. So why is advanced analytics and AI explosion is happening right now? So it's one thing is because there have been better algorithms. So if you look at the past 10 or 12 years, there had been a lot of new algorithms being invented. So things like you will be using algorithms like XGBoost or GBM. So these were introduced very recently. And the second reason being faster processors. So algorithms such as OLS regression was introduced in early 1800s, but people couldn't really make much use of it because they didn't really have the computation power. So since we now have very fast processors, we can use we can make use of those algorithms very well. And then the third reason being cloud technology. So you don't really need to have a supercomputer to use these algorithms. Since we have cloud technology, you can always log into the cloud, and the cloud will get accustomed to the need of your processing need. So because of this cloud technology, there had been a lot of explosion in advanced analytics, and also more data. Whatever we do, we tend to generate data. So even as we speak, we generate data. So whether it's structured data or unstructured data, there had been so much more data coming in the past 10 years or so. So these are some of the reasons why advanced analytics has been so much more important in the past, in the recent past. So we will look at one of the very, very interesting applications of advanced analytics and machine learning. So a CPG company actually wanted to set up new store locations in a very populated city like Tokyo. So everyone know that Tokyo is the most densely populated country in the world. So so they actually didn't want to set up one or two outlets, but they wanted to set up more than 600 outlets. So they were so much more ambitious. And also, recent store openings have been very disappointing. So they wanted to have a more scientific way to identify new store locations. So for these 600 locations, they wanted to identify what are the best locations. So what did the scientists do? So they used internal data and then they used external data to derive insights as to which locations are prime locations, which locations are the best suited locations for opening new CPG outlets. So they came up with very interesting insights, such as, so if you set up an outlet very close to a gas station, it will have a higher footfall. So it generated insights like these. So over 1,000 new locations were identified, and it this use case brought in so much value to the company. So this is one of the very interesting applications of advanced analytics. And the reason why I brought this up also was that, so there are so many problems that we can solve using advanced analytics, and we have to it's better that we make use of it when we can. So we will go on to some of the technical details of model selection and metrics. So if you look at the artificial intelligence umbrella of artificial intelligence, machine learning is just a uh, one subset of it. And machine learning can be divided into supervised learning and unsupervised learning problems. And then the deep learning sits right in between. So in deep learning, they use algorithms pertaining to supervised learning problems and also unsupervised learning problems. So uh, so we will look at supervised learning problems. So in supervised learning problems, based on the target variable, the problems can be divided into categorical. The problems can be divided into regression problems and classification problems. So in classification problems also, you have binary classification problems, multi-class classification problems. And in regression problems, you will always have the dependent variable as a numeric variable, such as also a problem that is often solved using regression is that things like sales forecasting and house pricing forecasting, so things like that. And you will likely be getting a regression problem for your Kaggle competition also. So so there are the models that we use to solve these problems also differ based on the uh, on the um, on the dependent variable that you have, whether it's a categorical variable or a continuous variable. So if you look at so we will actually look at regression models, since that's the area that will be very useful to you. So in regression models, what it tries to do is it tries to estimate the relationship between dependent variable and independent variables. So in this case, you are looking at a relationship between a dependent variable and one independent variable, and it calculates the error. So the error will be what it tries to do is that it tries to fit a linear line um, that minimizes the sum of squared errors. So the residual will be the difference between y and the predicted y. So that's what regression models, especially an OLS regression, tries to do. So let's look at a example problem. So here we have historical data of rent per year. So rent per year is, so you have a number of x variables. So you have the the distance to the next pet shop, and the size of the apartment, and the year this was built, and the distance to the center of the city. So those are the x variables. You have the y variable. So you have the regression problem. So using these x variables and the y variable, we can actually approximate a relationship. So say, for example, if you run a OLS regression, it will give you a coefficient as to, okay, so if the size increases by 1 square meter, the rent per year increases by a certain amount. So you will get a relationship like that. So once you have built your model, you can actually fit it to new data. So you will have the number of x variables. So you will have the next pet shop, the distance to the next pet shop, and the size, and the built year, and the distance to the center of the city. And using this information, you can actually approximate what the rent per year would look like. So that's how prediction works. So the goal in a prediction, so in a regression problem, is to get the best complexity to achieve the best. So the goal here is to get the highest quality of prediction with the least complexity. So achieving highest quality and achieving least complexity, as you can see, are goals on two sides. So you can't, you will realize that it's very difficult to achieve both at the same time. So say, for example, one way to increase the prediction power is to have more independent variables. So you keep adding more independent variables, but what happens is that it will increase the complexity. So the complexity leads to overfitting. So it's your goal is to achieve the best prediction power with the least complexity. So there are advantages to having low complexity models also. So very high complexity models are ugly. So it's literally and figuratively, because um, you will need to have low complexity models to avoid generalization error. And if you have a simplified model, it's very easy to understand too. And say, for example, if you are running this on a cluster or on a cloud, creating all those number of variables will take a lot of computation power and take a lot of rupees or dollars out of your pocket too. So it's better to make the models as simple as possible. So for these reasons, it's very important that you make your models as simple as possible, but at the same time, achieving highest accuracy. So as much as you want to uh, make your model simple, you want to make sure that the right models are selected too. So so look at this example. So say, for example, if you have, so say you are working for a marketing company, and you want to run a regression between rating for a certain product, the rating for a certain product, and the relationship between rating and the age and the income. So you have your two independent variables and you run your regression. So when you run your regression, uh, it becomes clear to you that uh, age age has a negative correlation, and income has a positive relationship um, with the dependent variable. So since your results are a bit dodgy, you decide to look at the correlation matrix. So when you look at the correlation matrix, you have the correlation matrix right here. So in the correlation matrix, the age and the income is positively correlated, strongly positively correlated. So if two variables are strongly positively correlated, you actually shouldn't be using the both variables in the same model. So, so since you know this theory, you luckily avoid using both variables in the same model. So in the third table, you will see the results. So here you can see that now age and income have positively correlation with the rating of a product. So now you have properly suggested the company to target a higher population for your product, and also target people who are more affluent for your product. So if you had incorrectly run the regression, you would be targeting a younger population. So this is actually a real example. So this could happen to you. So that's why it is so important that you select your variables properly. Um, so when you run your regressions or whether you do your classification problems, so there are different error metrics that you can use, or metrics that are used to decide the goodness of fit. So if you are doing a regression problem, so there are different metrics that you can use. So you can use the R-squared. R-squared is the variation explained by the model. So that's the probably the most common um, metric that we have. So we also have mean squared error, or RMSE, and also you have median absolute deviation. You can also use graphical plots such as residual plots. So so we will be talking about these metrics in a bit. And then when it comes to a classification problem, you can use metrics such as accuracy. You can use contingency tables, such as you can see the true positive rates, false positives, and also you can derive recall and precision. So these are the metrics that you can use. You can also use the ROC curve and the area under the curve and the Gini coefficient. So this is for classification problems. So any questions up until this? Okay, I will move on. Um, so uh, so there's no best measure when it comes to metrics, error metrics. So if you look at these two graphs, so first one is an OLS, a model fit using OLS regression. So if you look at this graph, so first try to look at the graph on your right hand side. So you will see that graph properly and nicely fits the observations that are lining properly. And then there's the outlier right here. And but if you look at the OLS regression, which uses mean squared error, the predicted line has sort of shifted towards your top right corner of your top right corner, because there's an outlier. And in median uh, in this graph where it uses median absolute deviation, it sort of ignored the outlier, and it has properly fitted the data points that lie together. So what's the best error metric? What's the best error metric to use, in your analysis? It always depends on your judgment. How important these error metrics are. How important these outliers are. So if you really want to model these outliers, you better use OLS regression or use um, a method that uses mean squared error. Or if you actually want to ignore the outliers, you better use median absolute deviation. So that's about the choice of error metric. So say that you have run your regression, right? And you want to see the goodness of fit. So you have fitted a graph between actual versus predicted. So you have on your first here on your y-axis you have the predict. I hope you can hear also. So so if you look at this these instances, so in the first instance you can see that the actual versus predicted has been plotted, and then in the second one you can see that the predicted versus residuals has been plotted, and then in the third one it's the time versus residuals. So can someone tell me what's the problem with these plots? You can just take a guess. You can just pick a graph and say what the problem you see is.
So, and then what he did was we went through some of these concepts of RSquared, right? So RSquared is this important metric, right? It will allow you to understand the percentage of variation explained by a model from a given feature or features, right? And also we went through the mean squared error, root mean squared error, and also we went through in terms of for the classification problems, we went through with the confusion metrics, right? So generally these concepts, universities, they teach these things too, precision, recalls, but there are other matrices that you should even looking into. So I mentioned a couple of matrices. You should go and looking into that. Like one is how we wanted to look into the performance if you have an imbalanced cross data sets, MCC type of matrices. So make sure you looking into those things. It might be handy in especially in the Kaggle competition, but most of the Kaggle competition problem will be using this particular model performance sessions, right? So if you can follow up these things, that's good enough for the next problem. Okay. So in here, after that, I went through these concepts of the residuals, right? And the predicted error and the actual errors, and also these residuals, right? So if you look at this particular problem, right, in here, the residuals, the high residuals in this particular area, right? And so there's only one metric is not going to good enough, right? If you look at this particular problem, like, so all these in the larger values, they are kind of started to like underestimated. So I mean, it's all these predictions are somewhere here, right? Somewhere here. Okay. So one metric is not sufficient to good enough to get like a conclusion at the end. So you need to look into several matrices as well. But in the competition, we have put a one particular metric that we are really looking after. So make sure that when you work on the competition, in the problem, the matrices are given. These are the matrices that we are going after. So make sure you fully focus on that particular problem, right? Okay. So the main problem will be either in a classification or either in regression. So one of those. Okay. So in a summary, right? And so we usually try out different models, right? And also we need to tune parameters in such a way that you can get a better accuracy. But accuracy is not only the main point or the main metric you have to go after. Sometimes you may have to trade off between time and the cost. So in this particular competition also, there's a time bound, right? So you can't train the models for n amount of days, right? There's a time bound. How many days do they have? Or 2 days or 12 hours? So there'll be some time bound, right?
2 days, 2 days, and additional 24 hours for the report submission.
Okay, so you will have 48 hours. So now it's a you have to take a decision, right? Where I'm going to stop it, right? So generally, so you have a trade-off between performance, accuracy, so the accuracy or the other matrices that you are going after, and also you need to go after the time bound and the cost. Okay, so in a nutshell, like you have to identify the particular problem, you have to understand the evaluation matrices. So in this particular problem, evaluation matrices are given from us, right? So you need to split the data sets. That's also pretty much given to you. And you need to build these evaluation matrices where you need to spend quite a bit of time in terms of generating features, right? So there's quite a bit of work you need to do in terms of feature engineering. What type of feature engineering, what type of parameters we have to tune, and you have to play with different models. And then once you select the particular model, you have to do the evaluations, right? So this is pretty much into the model performance and the matrices, right? And also we want to touch base a couple of things, especially in the last stage where most probably these are pretty new to you, where we call translating the insights. So you generate a model, right? And so what are you going to do with these particular models, right? So it has to have some meaning, right? Otherwise, so you generate some model, but it is useless, right? So I'm just going to introduce a model or a framework, which we call Baker framework, right? So these are the 4 key questions that you need to ask when you create a model, right? So number 1 is whether it has a bias, right? So when you have this bias factor, we call this B factor in the Baker framework, it's a bias factor, right? So there are a couple of biases, especially we can look into that. So some, for example, like even we use in the day-to-day life too, right? For example, like let's assume that you are sick, right? So maybe your mother doesn't want to go to a doctor, right? Because of COVID, right? So she started to pray for you, right? Okay, my son or my daughter, make sure that she's safe. So it's now she's believing. She started to believe this. So we call this belief bias, right? Sometimes you have what do you call this? Let's see whether it's healing or not. Okay, so sometimes you have different biases like IKEA effect too, right? Or sometimes you have a bias on such a places like if you train the model for longer period, you believe that the accuracy will be better. So these are biases. So it comes to the bias factor. Okay. The second one is we call this E factor. Yeah, we call this equal conditions. Right. So when you're looking into these problems, or when you developing the models and when you're testing the stuff, you need to make sure that you have the same conditions or equal conditions, apple to apple comparison. Right? So you can't train something in apple and then test it out in oranges. Right? You have to have this E conditions where all the things are a match, right? So the third one is in this Baker model, it says causal factor, right? So in a nutshell, so look, have you challenge for causality, or it's a coincidence of observation? It's in a very simple example, right? So in a let's assume in hot weather, right? In hot weather, so you can see in a particular day, right? Let's say in Colombo, so the weather is rapidly starting to go up, right? Around 11 o'clock, 12 o'clock. And then maybe there's an ice cream person who's selling ice creams, right? So in here, his income is also going to increase around that time too, right? So if you look at a 1D chart, how the weather changes from 0 to 24 hours on a particular day in Colombo, and also maybe the income of a particular ice cream vendor from 0 to 24 hours, right? So you might see like a similar type of trends going on, right? So when you have these type of things, so there's no dependency between the weather and the someone's sellings of ice creams, right? So this coming of these causal factors. The fourth and the most important factor is we call this is actionable, right? So you generate some model, right? So you come up with insights. Now it's not only good enough, so you need to come up with some intervention strategies too, right? So maybe one particular model will say, let's assume that you are working on a telecommunication domain. You want to understand who is actually let's say going to move out from that particular telecommunication company. Let's say telecommunication company A, right? So he's moving out. So we need to understand who is actually going out, right? So then, okay, we can create a model that basically telling that Yasuru is going to move out from telecommunication company A. Is that good enough for telecommunication company A? It's not good enough, right? So we need to understand how can I keep Yasuru, right? So we understood that he's going to go out, but if we don't do anything, anyway, he's going to go out, right? So the model will say that's it, right? But as a data scientist, we need to go a little bit more as well, where you need quite a bit of help from the business units. And also in analytics domain at OCTAVE, we have called this delivery team, right? So we need to come up with some intervention strategies where these intervention strategies can be actionable as well, right? Can you translate the analysis into something? Let's say move out from telecommunication. Maybe we can come up with some strategies. Hey, Yasuru, we have some new package. We need to give you 30% discount. That might help telecommunication A to keep Yasuru. Okay, so this is called actionable type of items. Right? So this might be helpful when you are working on the computation number 2, which call this the semi-final and the final rounds. Right? So we want to touch base a little bit on these areas as well. Given the time and the power and the internet, so I'm kind of speeding up. But the main thing that you wanted to understand is the Becker framework. It's called BECA, right? Whether your models are bias-free, whether you are testing out in the equal conditions, right? Are they comparable? And whether you have causal factors, and are they actionable insights also you are generating. So we call this Becker framework. Okay. Okay, might go to the key takeaways from so these are pretty much introduction, but so I'm not going after these visualizations for the time being. So I'll go after the key takeaways that you wanted to take away from this particular session today is, right? So we went through a couple of modeling techniques, especially we were heavily focusing on the model, different type of models and different type of model matrices. And this particular created in such a way, it's kind of targeting your Kaggle competition one. Okay, so make sure you go and looking into some of these concepts in the next 2 days, and you will be ready for the Kaggle competition. Yasuru, I hope it's on Friday, right? Friday to Sunday.
Yeah, from 25th midnight to 27th midnight will be given to cracking, and another additional day will be given to submit the report.
Okay, cool. So so make sure you understand these things, looking into if you don't understand any concepts of that model matrices and feature engineering, right? So the competition is heavily looking after that, and also we are providing the matrices that we are looking after. So you might have only one metric that we are really looking after, even though we taught you a couple of matrices, right? So that's the one of the key takeaways. And the second one is I would like you to understand about the Becker framework. It's only the concepts, the BECA, so which might be handy in your next rounds, right? So this is what we wanted. We will provide a question, and then you have 48 hours to solve the problem, and you need to submit your final testing results for particular model that we are going after in that particular problem into the Kaggle system. So then it will automatically generate the scores and ranking and stuff. So that will take you 50 points. Okay. So there's another 50 points we are going after from your reporting. Okay. So we are looking at how we have looking into the given problem, how we have defined the problem context, how you identify the gaps, have you identified the correct modeling techniques, have you done any feature engineering, what are the techniques we have done, what are the explorative data analytics. So you make sure when you write these reports, you highlighted all these key areas that you went through with your team members, right? What are the graphs or what are the visualization techniques we have used, right? So that will carry another 50 points, okay? And also if you are in a position, you can go after a little bit more what you can do from the model as well. But in the report, it has to have introduction, problem context, the techniques that we have followed in the problem, especially targeting the exploratory data analytics, right? And data modeling, what are the hyperparameter tunings that you have done, right? What are the models that you have tested out? So you might submit one model in the competition, but initially you might have tested out 5-6 models, right? It might be still worth it you to put the results. So make sure you keep those results in at least in Excel table, so you can put it into the nice table on the report, so you can see like how we have progress, right? So make sure don't delete those results. So keep it up. So we wanted to understand how we have grown up in the problem, right, that we are going to solve. And the final experiments that we have done with the training set, how we have split it up, what are the techniques we have used, how did you test the results, and so on and so on. And then you can, okay. So that's what we are expecting. And from OCTAVE side, we wish you all the very best. And so we will select, I think, 15 teams based on report plus the model, right? It's really important that you spend equal amount of it's not the time, equal amount of effort for the report as well. Okay, so you might score like good points for the Kaggle competition, but if you haven't submitted a report, that will be 0. Okay, so make sure you spend quite a bit of effort in the extra day that they have given to you. Okay, so that's